Welcome to this session. Earlier in this module, we've been looking at examples of project-based learning from across Europe and how to design your own projects with students. In this session, we're going to look more specifically at how you can develop students' collaborative problem-solving skills within a project-based learning environment. This session will help you explore the nature of collaborative problem-solving, enable you to differentiate between group work and collaborative work with your students, and finally provide you with guidelines for developing your own collaborative projects. To help us understand how, I'm joined today by Professor Patrick Griffin, Director of the Assessment Research Centre at the University of Melbourne. So Patrick, we increasingly hear a lot about the importance of collaborative problem solving as an essential skill for dealing with the complex personal and professional environments we live in. But what exactly is it?
Well, we could give a fairly formal definition of collaborative problem solving. We'd say, look, it's got to be two or more people interacting, working together to solve a problem for which they have a common understanding. And if we can develop that common understanding of what the problem is and what the steps are, what the resources are, then we have two or more people working with pooled resources in order to develop an understanding of a problem, set goals, and to come to an agreement about a solution. Non-routine jobs, collaborative, communicative, critical thinking jobs are developing. Routine, repetitive tasks are so easy to automate so that they're disappearing in terms of people doing them. For schools, the things that are easy to automate are easy to automate in the classroom as well. And the skills that we need in an information economy like collaboration, critical thinking and communication skills, they're not easy to automate. So that puts pressure on teachers as well.
Could you explain to us the social and cognitive skill areas that collaborative problem solving relies on?
We often see in teams and groups that we've got what we call lurkers, people who watch what the group's doing but don't actually contribute or participate. In a collaborative thing, participation is absolutely essential of every party, every person in the group. Not just to participate, but to be able to see the task from the different perspectives. I like to be able to see it from the way you look at it, you should be able to see it from the way I look at it. So this idea of taking the perspective of another person in order to shape the way you contribute is quite important. And then finally, the way in which we organise ourselves as a group, as a team, as a collaborative group, to address the problem or finish the task also needs to be organised. We need some responsiveness. I need to respond to what you do. I need to negotiate with you in terms of skills and contributions. So that kind of social, what we call social regulation, becomes quite an important task. The cognitive skills become also quite important. We need to be able to explore the problem, the project. We need to be able to work out what are the parts of it. How does it all build into a single problem? Which parts would you do? Which parts would I do? Which parts would another person do? And if I'm going to do part A and you're going to do part B and someone else does part C, what resources do I have to bring to that part that I need to do? The critical thing is that I can't do it on my own, you can't do it on your own, the third person can't do it on their own. They have to be able to collaborate with us by analysing the task and working with us to know who's doing what part, with what resources, and then at the same time we need to be able to explore the problem and the progress that's being made towards solving the problem. And that's a process in and of itself, and what we need to be teaching in schools is the idea of analysing what's called the problem space. What are the bits and pieces of the problem? How do they come together? Can we see patterns of relationships between these parts? Can we see rules or contingencies? If I do this, does that happen? So if-then type rules, so that we can experiment with that together in solving the problem. If I put my resources in and you don't, what happens? And then finally, can we get to the point where we could say, this always happens, it's a generalisation. But in this world, nothing's firm like that. So we need to be able to get our students in the school to say, well, hang on, what about, or what if? And when we get students working at that level and thinking like that, they're testing hypotheses. And it's really a high level of skill that they're working through. So that's the knowledge building type of cognitive skills.
What is the role of the individual participant in a collaborative problem-based project?
the big role is to contribute. So we talk about critical thinking, communication, collaboration, but there's another C. It's contribute. A collaborative task can't be done by individuals working alone, nor can they be done by a group of people working together with one person doesn't contribute. So the difference between collaboration and group work is that everybody must, and we'll come back to that later, but that's the role of the individual. You must contribute, you must participate, you must look at the problem from different perspectives. You must know what your role is and what the other person's role is. You must be able to analyse the problem space, and you need to be able to learn to take the thinking to higher levels.
So you've just explained to us that each participant's role is essential in a collaborative problem-based project. But what is it exactly that distinguishes collaborative problem solving from problem solving by an individual?
Well, communication is probably the one word that does it. If we're doing just individual problem solving, like we do in the PISA studies, we think a lot, we work it out ourselves, we write down our solution, and we pass our solution on to somebody else to make a judgment about the quality of our solution. But it's covert. There's nothing outward being done. There's no communication there. It's all cognitive work. In a collaborative task, everything we do has to be directly observable, and it's all evidence-based. And evidence is a very interesting thing. It's not how much we know, it's not how much we understand, and it's not how much we think or how much we feel, because none of those are directly observable. So when we're collaborating, we have to use 4 things. It's what we do that other people can see. It's what we say that other people can hear. It's what we write, which other people can read. And it's what we make or produce that other people can use. So that's the contribution and the difference between collaborative problem solving, which is overt, evidence-based, do, say, make, write, as distinct from individual problem solving, which is about think, feel, know and understand. One is inferential, the other is evidence-based.
What is the best medium for delivering a collaborative problem-based project?
It's hard to know what's best. We've just come through 5 years of working through problem-solving tasks being administered through technology. But it's not the only way it can be done. One of the things that we illustrate is that we have a science task called the beam balance and putting weights on a beam balance to get it level. But I was walking through a playground and I saw a seesaw where kids had obviously put rocks on a seesaw to balance it. When you think about that, they had to know what the problem was. They had to work out who had the big rocks, who had the little rocks. They had to have an idea of how to balance it and a plan, and then they had to work out how to work together to solve that problem and to put the rocks on. When they finally got it level, they could, if they wanted to, say, well, let's shift the rocks around and see if we can arrange them in a different way. So you can do it face to face. And teaching it face to face is probably the best way to teach the idea, particularly if you can then get the students to reflect on that process. What did you do next and what did you learn from that step, and that kind of questioning with it. But assessing it's another matter altogether, because if you've got 30 kids in a classroom working in 2s and 3s, all talking about the problem that they're trying to solve, it would be a cacophony in the classroom, an impossibility for a teacher to observe students. So while technology might make it a little artificial, it actually controls the process for us a lot more than the freewheeling of a classroom.
Can you take us through the concrete steps teachers need to take in order to design and implement a collaborative problem-based project?
The key task is, what's the problem? What are the parts of the problem? What are the resources that we can distribute amongst the students? And then can we get them to document the process that they're going forward? And when they're finished, challenge the students. Could you do it another way? Could you get a better solution?
So finally, what is the role of formative assessment in shaping teaching so that it effectively develops students' 21st century competences associated with collaborative problem solving?
Well, clearly the role of formative assessment is always to improve the student's performance. But in fact, the real role of formative assessment is to change the teaching practice, because unless you change the teaching practice, you just reinforce the status quo with the students. So, to what extent do the teachers need to understand the problem elements, the participation, the perspective-taking skills? To what extent do the teachers need to understand the analysis of the task and even that hierarchy of knowledge building? They all need to know that for sure, so that they can recognise the evidence that's being produced by the students. And they can begin to challenge the evidence. And one of the best forms of formative assessment would be the teacher doesn't say, that's good, that's great. It's what if? It's what would happen if? How would the problem be clearer if you and your partner and your partners change the way you put that together? So that we always use formative assessment in a challenging mode, which at the same time needs to be reinforcing and positive. Not, how did you do that? Or, I didn't think you'd be able to do that. No, it's about, let's say we tweak what you've done a little bit and we add another rock to the seesaw, or we do something to get you to think a little bit higher about the problem. Now, that presupposes that the teacher has this idea of a progression of increasingly higher thinking in the mind as well. So that while I'm, as a teacher, challenging you as the student to think a little bit about the problem that you've worked on, where on this progression are you? And where am I trying to put you to get you to go up to the next level? So it presupposes that I know the problem. It presupposes that I understand the progression of thinking, the development of thinking, and it presupposes that I can challenge you to think more about going to the next level. That's formative assessment.
Thank you very much, Patrick. We just heard briefly now about the importance of formative assessment, and Patrick will be focusing precisely on this in more detail in Module 3, where we'll be looking at methods and tools for assessing collaborative problem solving. We look forward to meeting you again then. In the meantime, you can access further reading and related resources to this session from our course library. Do also take the time to visit our course forum to join in on this discussion about this topic. Thank you.